Hello everyone. Today we are going to discuss about quadratic equations, February and March shift JEE mains papers, so that it will be helpful for next shift exam. So let's start with February shift, March shift. The number of elements in the set. Okay, this was the question. Number of elements in the set mod x minus 3 into mod x plus 4 is equals to 6. Okay, so how many elements will satisfy the given condition, that we need to find, and we don't require the exact values of x, we just require how many elements. Okay, so this we can do in two ways. One is directly using the condition like mod x is equals to x when x is greater than 0 and minus x when x is less than 0. So using those conditions we can do, or else we can use graph. Okay, in this mod x minus 3 and mod x plus 4 is equals to 6, I am making like this: mod x minus 3 is equals to 6 by mod of x plus 4. Okay, this is actually mod x function, but it is subtracted with 3. So if you see the graph, let us consider a y-axis and x-axis. Mod x will pass through 0, but here we have mod of x minus 3. So when x is 0, y will be minus 3. So we have the graph like this. It is of v shape, and we can also say when it will intersect x-axis. When it will intersect x-axis, y coordinate should be 0. That means mod x equals to 3. That means this is 3 comma 0, and this is minus 3 comma 0. This is mod of x minus 3. Now we need to draw the other graph. That is y is equals to 6 by mod of x plus 4. Okay. So it is like x into y is equals to c square. So this is nothing but a hyperbola. It is nothing but a hyperbola. And when it is undefined, when x is minus 4, it is undefined. When x is minus 4, it is undefined, and when x is 0, the value is 3 by 2. The value is 3 by 2. Okay, so when you are increasing the values of ex, when you are increasing the values of x, the value of y is decreasing, and slowly it will close to 0. At the same time, at 4 it is undefined. So this is for the positive side and this is for the negative side. Okay, so right, this is the graph of mod x plus 4. You can clearly see that these two curves are intersecting at 2 points. Okay, this is one and this is one, and we don't require what are those points. So directly number of elements in the set will be 2. This way we can do. Next, question number 2. P of x is equals to ax square plus bx plus c is a quadratic polynomial. Okay, so they given with integration this one. Yeah, p of x is equals to x square plus bx plus c, and first I am using this given integration condition, that is 0 to 1 p of x dx is equals to 1. So that is, if you integrate it directly, I am writing x cube by 3 plus bx square by 2 plus cx. Okay, just we are integrating p of x and the limits are from 0 to 1. which is equals to 1, they only given. So if you keep 1, that value you will get, and 0 will be everything 0. So 1 by 3 plus b by 2 plus c is equals to 1. So from this, b plus 2 into c by 2 is equals to 1 minus 1 by 3. That is nothing but 2 by 3. So we have, by doing cross multiplication, 3b plus 6c is equals to 4. 3b plus 6c is equals to 4. This is one equation, because the unknowns are in terms of b comma c. Now we have one equation, we need to find the other equation. They're saying that p of x leaves remainder 5 when it is divided by x minus 2. So using remainder theorem, p of 2 should be is equals to 5. So what is p of 2? 2b plus c is equals to, this is 5 and we already have 4 now, so this will be 2b plus c will be 1, and you can multiply this with 6, so that is 12b plus 6c is equals to 6. This is equation 2. So we can do equation 2 minus 1. Equation 2 minus 1, if you do, that will be 12b minus 3b will be 9b. 9b is equals to 6 minus 4, which is equals to 2. So b is 2 by 9. If b is 2 by 9, c is equals to 1 minus 4 by 9. So that is equals to 5 by 9. So b plus c is 7 by 9. They are asking 9 into b plus c. So the required value will be 7. The basic problem only. Just we are integrating, we got one relation, and using the remainder theorem, we got another relation. So that's the thing. Now, let's see third one. So in this is given thing, y is equals to, if I take 4 plus 4 plus 1 by 5 plus, and again this part is given as y only. See, it's the same thing. So we have to write it as 5 plus 1 by, we assumed y is equals to 4 plus this whole thing. So 4 plus this whole thing means again it is y only. So that is y is equals to 4 plus y by 5y plus 1. Okay, so we can do cross multiplication, that is 5y square plus y is equals to 21y plus 4. So from this, 5y square minus 20y minus 4 is equals to 0. It's a quadratic equation. Okay, so we can, there are no factorization is possible. So directly we can take y is equals to minus b plus or minus root b square, that is 400 minus 4ac. So this will be 480 by 2a, it will be 10. But the given thing is all positive signs, then it cannot be negative. So negative sign is not possible. Negative sign is not possible. So that case is excluded. So only one value is possible. So that is y is equals to 20 by 10 will be 2 plus this 480. Okay, 480 means 16 into 30 we can write. That will be 4 into root 30 by 10. So it's nothing but 2 plus 2 by 5 into root 30. So it is option 1. So this way we need to solve exactly the this way. And actually in one of the next problem also, 18th March shift 1 also same problem is given. So we can solve in the same way. You can see that. Exactly the similar question. Say 3 plus something, again 3 plus something. So here if I take x, that is 3 plus 1 by 4 plus 1 by x. So in the same way we can do it. Yeah. So let's move to the last question in March shift. Here f of x and g of x are two polynomials such that p of x is this way. They're saying that p of x is divisible by x square plus x plus 1. So we know that this discriminant is less than 0, and what are the roots for that? Omega comma omega square. That means the whole function is divided by this quadratic, means it is also divisible by omega and omega square. That means p of omega should be 0. What is p of omega? F of omega cube, that is 1. So f of 1 plus omega into the g of also 1 equals to 0. This is one relation. Now p of omega square also should be 0. So p of omega square is 0. That is f of omega power 6. Omega power any 3 multiple will be 1 only. Then omega square plus g of again omega power 9, that is also 1 only. This is the relation. So now they are asking p of 1. So for that I'm just adding these two equations. It is, they're asking p of 1. What is p of 1? F of 1 plus g of 1. This is our requirement. F of 1 plus g of 1. Okay. So when I'm adding these two equations, equation 1 and 2, that is 2 times of f of 1 plus omega square. We knows 1 plus omega square is 0. So omega plus omega square is minus 1. That is directly I can write it as minus 1 into g of 1 is 0. That is 2 times of f of 1 is equals to g of 1. 2 times of f of 1 is equals to g of 1. So here p of 1 is nothing but 3 into f of 1. P of 1 is nothing but 3 into f of 1. Okay. But they are asking numerical value. They're asking numerical value. Here we got the relation p of 1 is equals to 3 into f of 1. So in the same way, equation 2, if I multiply with omega, that is omega into f of 1 plus omega cube, that is 1. So plus g of 1 is 0. Okay. So f of 1 is nothing but g of 1 by 2 only. So g of 1 if you take common, if g of 1 if you take common, that is 1 plus g of 1 is 2 times of f of 1. So f of 1 is 2 times g of 1 by 2. That is 1 plus omega by 2 is 0. This is not possible. Omega is cube roots of unity. So that's not possible. Only possibility is g of 1 is 0. If g of 1 is 0, f of 1 is also 0. That implies our required answer is 0. P of 1 is 0. See, this question linked with cube roots of unity, complex numbers. This way we can do. These are the questions asked in March shift. Okay, so let's move to February shift now. Yeah. So in February shift, this was the question. P and Q are two positive numbers such that P plus Q is equals to 2. P power 4 plus Q power 4 is 272. The given P power 4 plus Q power 4. What is P square plus Q square first of all? We can write like this now. P plus Q whole square minus 2PQ. So that is nothing but 4 minus 2PQ. Just keep it aside. We will use it here. Again, this is A square plus B square form. So that is A plus B whole square. A plus B whole square minus 2AB. That is 2PQ. P square Q square is equals to 272. So P square plus Q square is already given. That is 4 minus 2PQ whole square. So it will be 16 plus 4p square q square minus 2. So that will be plus 2p square q square minus 16pq is equals to 272. Now it is a quadratic equation in pq. So we can write it as t square. I'm taking 2 also common. Pq as t. So t square minus 8t. So this is 16. That said it will be 256. So minus 128 equals to 0. So 128. So we can write like this: t minus 16 into t plus 8 is 0. The given p and q are positive numbers, so it cannot be negative. Only possibility is 16. P into q is equals to 16. And we have p plus q is equals to 2. We now need to calculate the value. When sum of the roots and product of the roots is given, x square minus x into alpha plus beta plus 2 alpha plus alpha beta. So required answer is option 4. Just calculation is there and using the relation between coefficients and roots. Next question. Second question, the given A, B, C are in arithmetic progression. A, B, C arithmetic progression means 2B is equals to A plus C. Basic thing. And centroid is what? X1 plus x2 plus x3 by 3. So G they given as centroid. Okay, what is that? 10 by 3 comma 7 by 3. So using the vertices, it is 2 plus 2a by 3 comma 2b plus c by 3 is equals to 10 by 3, 7 by 3. So from this, what is the a value? Clearly x coordinate must be equals to x coordinate. So that is a is equals to 4 is visible. A is 4 and 2b we knows already, that is a plus c. So let me use that. 7 is equals to 2b, that is a plus c plus c. So a plus 2c. A is 4, so 7 minus 4 is 3. So that is c is equals to 3 by 2. C is 3 by 2. Now we have A and C. So B we can calculate. 2B is equals to A plus C. That is 4 plus 3 by 2, which is 11 by 2. So b is equals to 11 by 4. Now they are making the equation ax square, that is 4x square, plus bx 11x by 4 plus 1 is 0. For this quadratic equation, the roots are alpha comma beta. So that we need to find out. That is 16x square plus 11x plus 4 is equals to 0. So now they are asking alpha square plus beta square minus alpha beta. Alpha square plus beta square means alpha plus beta whole square minus 2 alpha beta. Already alpha beta is there. So sum of the roots minus b by a, which is 121 by 256. This is 3 c by a, so that is 12 by 16. So which is equals to 121 minus 12 into 16, that is 192 by 256. So this is nothing but minus 71 by 256. So this way we can solve bit calculation, okay, but problem is easy only. Yeah. Now this one, number of real roots of the equation, it was numerical question. Number of real roots of the equation, x plus 1 whole square x minus 5. So mod x minus 5, we know the nature of that. That is, when x is more than 5, that will become only x minus 5. When x is less than 5, that will be 5 minus x. Okay. So if you see x plus 1, one case is x plus 1 whole square plus x minus 5 is equals to 27 by 4. So which is x square plus 3x minus 4 is equals to 27 by 4. So 4x square plus 12x minus 16 minus 27, that is minus 43 equals to 0. This is one of the equation. Check the other equation also. That is x plus 1 whole square plus 5 minus x is equals to 27 by 4. So if you see x square plus x plus 6 is equals to 27 by 4. 4x square plus 4x minus 3 is 0. So this case is when x is less than 5. This is when x is more than 5. Now we require just number of real roots, so we don't require exact solutions. So once check this discriminant x is equals to, or else directly we can solve it also, minus 12 minus b plus or minus b square 144 minus it will be plus. Okay. So some big number is coming, but we won't consider minus. Why? Because x value should be more than 5. So from here only one real value. From here only one real value. Now check discriminant of this in the same way. X is equals to minus b plus or minus b square 16 plus 4ac, that is 48 by 8. So if you see that minus 4 plus or minus 16 plus 48, it will be 8. So by 8. One case is 8 minus 4 by 8. So it will be 1 by 2. That's fine. Then minus 12 by 8. That is also we can take because both of them are less than 5 only. Both of them are less than 5. But whereas here one is less than 5 because negative number. So overall we have three solutions. 3 real solutions is the answer. Okay. Now let's check the fourth one. They link this question with probability. The coefficients of a, b, c of the quadratic equation ax square plus bx plus c is 0 are obtained by throwing a die 3 times. So it is obtained by throwing a die 3 times. Okay. Probability that the equation has equal roots. Equation has equal roots means what is the condition? Delta is equals to 0. That is b square must be is equals to 4ac. B square must be is equals to 4ac. Here we are throwing a die 3 times. So sample space is very clear. What is that? 6 cube, which is 216. So using these outcomes, we need to select A, B, C. So A, B, C. So for what values it will satisfy? Like this condition should be satisfied. B square is equals to 4AC should be satisfied. So check for that. If B is 2, A is 1, C is 1, satisfying. We can check it. Like that, how many possibilities are there? Okay, that we need to check. One is 4 square 16. So already we have 4. So this will be 2. This will be 2. One more we got. Yeah, I can keep 8 also in the same way. 8 square is 64. 4 is possible. 4 is possible. Yeah. Only maximum possibility is 4, 5, 6 only. So 6 if you keep, that is 36. 6 if you keep, 6 square is 36. So 4 into 9 should come. That is 3 into 3. This is one other possibility. Maximum possibility is 6 only. Any other possibility? Five square we cannot take it. Means b square should be divisible by 4. B square should be divisible by 4. Yeah. That means total possibilities are 4. So favorable are 4. 4 by 216, which is nothing but 1 by 54 is the answer. Okay. Yeah. Next, fifth question. In fifth question, they given a quadratic equation where x square coefficient is positive. X square coefficient is positive. Okay. And the whole expression is giving you positive. That means discriminant must be less than 0. So discriminant, if you see, b square should be there. That is 4 into 3k minus 1 b square. Okay. Minus 4ac. So that is 8k square minus 7 should be less than 0. So now if you see 9k square plus 1 minus 6k minus 8k square plus 7 should be less than 0. So k square minus 6k plus 8 should be less than 0. So now the integer k for which the inequality is valid. Okay, that means here if you solve using wavy curve, k belongs to, so it's nothing but k minus 4 into k minus 2. So that integer should be between 2 to 4. So between 2 to 4, there is only one integer, that is 3. Okay. Very important this one. X square coefficient is positive and the whole expression is always positive. So discriminant must be negative. This is the condition we used. Then, yeah, this is a quadratic equation question actually. You see, they given one root for the equation, that is complex root. Alpha comma beta belongs to capital R such that 1 minus 2a is a root of this equation. 1 minus 2a is the root of the equation means if you substitute that 1 minus 2a, it should satisfy. It should satisfy that 1 minus 2a. So check it. 1 minus 2i whole square plus alpha into 1 minus 2i plus beta is equals to 0. So in this way, 1 plus 4 into minus 1 because I square, then minus 4i plus alpha minus 2i alpha plus beta is equals to 0. Left side we have real part and imaginary part of a complex number. What is real part first? 1 minus 4 minus 3 alpha minus 3 plus beta. We have this is real part. Imaginary part, if you write I, then minus 2 alpha minus 4 is equals to 0. If this is equals to 0, 2 alpha is equals to minus 4, alpha is equals to minus 2. If alpha is minus 2, then alpha minus 3 plus beta should be 0 because right side there is no real part also. Real part is 0. Alpha is minus 2, minus 5. So beta is equals to 5. They are asking alpha minus beta. That is minus 2 minus 5. So your answer will be minus 7. Minus 7. Next. This was repeated actually. It was asked in 2015 JEE mains and they asked recently also. X square minus 6x minus 10. A(n) is alpha power n minus beta power n. So we know that if alpha is a root of the particular polynomial, f of alpha must be 0. Alpha square minus 6 alpha minus 2 is 0. Similarly, beta square minus 6 beta minus 2 should also be 0. So A10, that is alpha power 10 minus beta power 10 minus 2 into A8 alpha power 8 minus beta power 8 by 3 into alpha power 9 minus beta power 9. This is the information we have. Now alpha power 10 and alpha power 8 we can take common. What is common? Alpha power 8 is common. So alpha power 8 if you take, that is alpha square minus 2. Similarly, minus beta power 8 if you take common, beta square minus 2 by 3 into alpha power 9 minus beta power 9. So alpha square minus 2 is 6 alpha, beta square minus 2 is 6 beta. So if you see 6, if I take common, there is nothing but alpha power 9 minus beta power 9 by 3 into alpha power 9 minus beta power 9. So the answer will be 2. Just we use the basic concepts of polynomials from 9th class where we have started learning. Next, question number 8. This was numerical one. They're again asking a number of solutions. Number of solutions log base 4. So this I can write it as 2 square, which is 1 by 2. So x minus 1 whole power 1 by 2 base 2 is equals to log 2 base x minus 3. So same basis. So that is nothing but x square plus 1 minus 2x is equals to x minus 3. So in this way, x square minus 3x, it will be plus 4 is equals to 0. And this is a quadratic equation. If you solve this, x minus 4 yeah, the roots for these are imaginary. You can see that discriminant b square minus 4ac, so 4 into 4, which is negative. So there won't be any real roots possible. So the number of solutions will be 0. Okay, they should ask number of real solutions. Next, last one. Alpha and beta be two real numbers such that alpha plus beta is 1, alpha beta is minus 1. Pn they given as alpha power n plus beta power n. Okay, so p1 is clearly visible. P1 is 1 only. P1 is 1, that is visible. What about p2? What about p2? P2 is nothing but alpha square plus beta square. So alpha plus beta whole square minus 2 alpha beta, there is nothing but plus 2, which is 3. So p2 is 3. Similarly, check for p3. Alpha cube plus beta cube, alpha cube plus beta cube, that is what alpha plus beta whole cube minus 3ab, that is plus 3, into a plus b, that is alpha plus beta is 1 only. So we have p3 is 4. So P1 is 1, P2 is 3, P3 is 4. Now Pn minus 1 and Pn is given. So let's see from that. This is alpha power n minus 1 is equals to 11. From the other equation, alpha power n plus 1 plus beta power n plus 1 is equals to 29. So once you subtract these two equations, if you take alpha power n minus 1 common, that is nothing but alpha square minus 1 plus, similarly, beta power n minus 1, beta square minus 1 is equals to 18. This way we can write alpha power n minus 1, alpha square minus 1, beta square minus 1. Yeah. From this, what is the equation? X square minus the quadratic equation, x square minus x into minus 1, x square minus x minus 1 equals to 0. I'm taking alpha comma beta as the roots. So this one. So alpha square minus 1 is nothing but alpha only. Beta square minus 1 is nothing but beta only. So it's nothing but alpha power n alpha power n plus beta power n is equals to 18. This is nothing but Pn. So Pn is 18. Then what is its square? The answer will be 324. So just we are using the again relation between roots and coefficients of quadratic equation. So almost around 80% problems are easy only, which were asked in February and March. So you should not miss marks from quadratic equations. Be prepared. Thank you.